Okay, we're in section 12 of the notes. As you know, this section's all on this numerical integration stuff. We talk about a variety of techniques, and certainly you could certainly program this if you wanted to, which I would suggest you do. But you start to realize that are there numerical techniques built into a product like Sage? And the answer is, of course, there is. A lot of integrations you can't do by hand, and there's no antiderivative, so you're going to need some technique to do that. So what I'd like to do is just look at the code, and I want to try to understand, is this code related to what we've done in the problem set? Now, whether it's from my lecture or the examples or the homework that you may or may not be doing at this point, you may do it later, who knows, or you may have already done it. But I just want to go back to my instance of Sage. And remember, you can always go back to that magenta link, click on it, and do the co-calc. But I'm going to just type in reset, fairly easy to do. And we've been doing this for some time now. We're going to define a variable X. Remember, if I type something in wrong, it's not going to blow up. Then I say f of X is being assigned. Wow, what's this thing? Well, it looks like the absolute value of X. Let me type that in for you. ABS, that's the absolute value of X. And it looks like they're raising it to a power, and the power they're raising to is sine of X. Okay. And then I'm going to plot it, PLOT. And I'm going to plot the f of X. We'll see what it looks like. And between, let's see, it says between -5 and 20. Well, let's take a look what that looks like. That's good. Well, I graphed it. All right, that's good news. All right. So what I want to do is just go back over the notes. And part of that is just reflecting over, what is this about? And this is about something that we've discussed. And what we've discussed over here. Now, someone says, what's this code over here? Well, if you read the notes, it says it's Mathematica Code. Right? We don't have Mathematica anymore. Let me explain why we don't have Mathematica anymore. Mathematica is a commercial product, super expensive. The school was spending a fortune on having Mathematica for its students and faculty. All right. And of course, every year they pay Wolfram a big sum of money, so our students and faculty could have access to Mathematica, which is by far, I would have to say, the slickest computer algebra system on the planet, right? There's nothing that really compares to it, right? Really slick, all right? Unfortunately, what happened was the school did a little investigation about who's using it. Now, although I promoted it and I said to the students, you should learn how to use this stuff, and I would present seminars, I would write little tutorials on it, it would be embedded in my notes, yada, yada, yada. None of the students were using it, which is kind of sad. I mean, someone's giving you a resource that's not being used. And then the school says, are any faculty members using it? And it only was one. It was me. I was the only guy in the whole school using it. So what the school said was that it's outrageous to spend that much money on only one person using it. So they canceled the subscription to it. And that's when I said to myself, well, you know what? I need a free alternative. And that's why we went to Sage. So anyway, this is the graph. Let me go back over here to my little image. Not bad. Certainly I'm saying mathematics graph, this graph, relatively the same. I hope you realize that. And, I'm looking at the Mathematica Code. And again, they had a little hiccup over here, and they sit back and answer, all right, with the answer they spit back when they integrated it. And that was numerical integrate. Really the same type of command, by the way. And they said it's 44.8114. All right. I'm going to close the graph out. And I realize the problem that we've talked about. And I know it's difficult. I wouldn't want to do that one by hand. I couldn't do it by hand, by the way. I could certainly use the techniques we've discussed. All right. But I want to go back to Sage. And what I want to do is, go back to the Sage code that we were talking about. And again, I realize this is in my notes. The graph is there. Mathematica Code was there. But now what are we doing? We're using Sage. All right. And so I'm going to go back to use Sage. And what are we going to do? I'm going to type in NUM, and then I'm going to hit the tab button. And I want to see what comes up. A lot of things come up. And one thing I noticed that comes up is numerical integral. So I'm going to scroll down to that. You see what I'm doing? I use the hope. I'm going to put a question mark there, and I want to see what it says. All right. Now, what is this? I'm saying this is some kind of command, but I have a question about it. Let's see what it gives me. So it gives me this, what's called like a man page about how to deal with it. A lot of people look at this and go, oh my God, I just don't think I could ever read through all that stuff. But there's a whole setup about this numerical integral thing. And you could read through that if you want, a whole setup on it. All right. Now, again, I realize some people don't want to read through that. I just hit the Q button to get out of that, by the way. That's what's known as a man page or a manual. All right. So I'm just going to type in my code. I realize that might be a lot of reading for me, right? So let's type this in. What's a numerical? I'll hit tab again, and I want numerical integral. I hope you see what I'm doing here, right? And then f of x. And I want to integrate it from -4 to 15. And I'm gonna set a parameter here, maximum points. And certainly someone says, what are you gonna do? It's like the precision of this thing. It's gonna take 10 points. All right. Again, I didn't read the man page, right? You could read that if you want. A lot of options there. And do it. And what does it give me? It actually gives me an approximate value of that integral, and then it gives me some kind of an error number on it. All right. So I want to go back to the Wolfram code. Oops, right over here. And oops, not that one. I'm sorry. They got 44.8114. All right. Is it the same integral? It is. What did I do? I used nintegrate for Wolfram Mathematica. And for Sage, I use this numerical underscore integral to do the problem. All right. So I think it did okay. And I like the fact that it was able to do that. Now, certainly I'm going to clear the screen now. And what I want to do is I want to start to play around with software. All right. And this is the whole point of this. You know, you might say, oh, gee, I'm just going to type in almost like I'm in a bad job and I'll do exactly what they're asking to do, but nothing else. All right. And God, you know, I always say, God forbid you end up in a job like that, right? Where you're only going to do exactly what you're told and nothing else, like a really bad job. All right. You dread it every moment that you're there. You want to get into a field that you're actually, you know, capable of getting some joy from it. All right. I'm not saying this is it, by the way. This may not be it. I'm not saying this is going to, you know, the one thing you want to do is this thing over here, but I'm going to see if I can do this problem over here. All right. So I'm going to type in integrate. Oh, first of all, let me reset what I've always been doing, right? And I'm going to set X and T to be variables. We've been doing this for some time now, and I'm hoping you're sort of familiar with what we're doing over here. And I'm going to try to integrate. Remember, if I don't remember how to integrate, I go INT and then, you know, basically try to use a tab button and scroll through it. Integrate. You're going to make mistakes, though, by the way. I really mean that. And what am I going to try to integrate? Sine, the argument square root, x, right? And I want to integrate, I don't know, it's dx, right? And I'm going to start with 0 and go up with t, go to t. Now, before I do that, I can't remember if I told you this, but let's try it. Let's try what happens. Yeah, hey, look at that. It's just craziness. All right, there's something wrong here. All right, so, you know, it goes on to say it's t positive, negative for 0. It's got all kinds of things. So I'm going to clear screen again. Remember, clear doesn't, you know, do anything. I'm going to say assume. You see what I'm doing? I'm just typing. Assume t is greater than 0. All right, let me try that code again. Wow. Wow, wow, wow. It integrated it. I really mean that. Wow, wow, wow. It integrated it. I kid you not. All right. So what I want to do is I want to do this over here. A miracle. I integrated this thing. All right. I integrated this thing. All right. Now, by the way, when I'm reading that, I notice it's got something else that says, finding a t less than pi over square. I'm going to write this down now. Assume. Ready for this? T is less than or equal to pi squared. And now I'm gonna set a function. I'm gonna call it g of x. No, I'm gonna call it g of t. And what's g of t? It's equal to this integration over here. All right, so I know what g of t is now. Now, what do I want to do? I want to know for what value of t is g of t equal to 0. So solve g of t equal to 0. See what I did? Not 0, I want it to be 2, right? What am I doing? 2. You get the idea? For t. Let's see what happens. And it gives me something. It gives me something that says it can't solve it. It can't solve that problem. All right, and this is where numerical techniques comes. So I'm saying numerical solve. All right, so I'm going to see if I can just type the letter N in now, see how many things come up. And I realize that might be really overwhelming, right? So I'm looking for it. And let me see if I see anything that says N solve or numerical solve in it. No, I don't see it. All right. So what I'm going to do is I'm going to go to the web. Whoops, sorry about that. I didn't mean to do that. I didn't mean to do that either. I just jumped with my mouse there. I'm going to go back to the web. And I'm going to type in numerical. You're going to do this a lot too in a computer algebra system, numerical solve in Sage Math. And it says new. Oh, look at that first setup here. All right, I'll click on it. And over here, and this is something you probably have seen before. Something about solve and numerical solve. Nah, it wasn't too successful. So we can go backwards. This is part of your learning. I click on this link now, and this is something you've done probably many times before. And I'm kind of looking around. You know what? I think it might be find root. Find root. Let me put this down. Oh, I'm sorry. I got to go back to my Sage thing. So I'm going to type in, let me do this over here. Find root. I just did tap completion over there. And I want to do this over here. Okay. And then I'm going to say t from 0 to pi squared. Oh no, another error. At least 3 arguments. You know what? I got to go back. I made a mistake. 3 arguments. Let's see what the 3 arguments are. I'm looking at code over here. I said find root, right? Oh, I'm sorry. I really am. I didn't. I'm thinking that this is a solve problem, and it's not. So let me type this in over here. And this way, it's so nice to have access to other people's code so you can look at it. And I got a number over there. Now, I guess you might say stuff, gee, that's a lot of struggle. I don't think I'll ever do that. I enjoy doing that. I enjoy looking back over somebody else's code, trying to figure out how to solve a problem. Now, granted, I am not claiming that this is what they asked me to do, but what I'm claiming over here is that, it basically asking me to do it. And does this happen in, can you do this in Mathematica, of course, and the code I'm giving you over here is actually Mathematica Code. It's a little bit old. I give you nice little pictures. I did the integration for you. I solve it. And actually the exact value of t, you can do by hand is pi squared root of 4. Let me go through that with you. So on my Sage numerical approximation, remember, it didn't solve it exactly. It couldn't do it, but I can do it. So I can do things that Sage can't do, and Sage can do things that I can't do. But let me type in a number problem over here. So I'm going to say pi. You know what? I have to make sure you understand what we're doing over here. This is pi, but I want a numerical approximation to pi. And what I'm going to do with that, I'm going to square it and divide by 4. And what number do I get? Well, I hope you realize the number we're getting here is the exact solution to the problem. And over here, this is Sage's attempt at getting an approximate solution to the problem. Are they similar? Yes. Are they exactly the same? No. Right? No, they're not exactly the same, but they're similar. Sage has a very large precision on this over here. If you look at it, it's impeccable. It really is. But the exact answer is really the goal over here. All right. So I'm going to say, if you have Sage, play around with it. You're going to get stuck. You might have to go to the web. You might have to search for it. I can't remember commands sometimes. I got to search for it. Thank you so much for listening. And I hope you have some pleasure in using Sage. Again, we start off a little bit of code for you. You may want to see how this code applies to other problem. Let's get this deal straight, though. Sage really should not be done on the homework unless you're told to use a computer algebra system. What are you basically doing? Everything is being done by hand. It is so important that you learn to do things by hand. Thank you.